All right, so let's start with our third and last topic of our today's journey, which is containers and some other services and tools that you can find in Google Clouds. So let's start to talk a little bit first about containers inside Google Cloud. So do you remember this spectrum where we talked about the different kind of computational power that you can have inside Google Cloud? We said that we have the IaaS, infrastructure as a service, where you pretty much manage all the infrastructure yourself. That is Compute Engine, remember from the previous chapter. And then we know that there is the complete other side of the spectrum, which is the App Engine. It's a PaaS, platform as a service. We take care of everything for you. We take care of the infrastructure, the scalability, the instances, the type of machine, the locations, and everything. You just put your code and it works. I will tell you a little bit more about App Engine a bit later, but for now, we will take the middle solution. It is in between IaaS and PaaS in some sort. It gives you some sort of control over the infrastructure. It gives you some sort of control of the firewall rules, the policies, the permissions, and so on. But at the end of the day, it is still a little bit managed. And I'll tell you why this is good news. But before I rush into talking about containers inside Google Cloud, let's actually get an introduction to what is containers. And then let's also talk about what is Kubernetes before talking about Kubernetes Engine. So containers, what is the story? Before I talk about containers, let's actually talk about the current IaaS service that is being popularly used in most cloud providers. It is basically the way of creating a virtual machine and putting it on top of your hypervisor hardware and software that is managing your fleet of virtual machines together. So what you see here is something not necessarily related to Google Cloud. It's pretty much wherever you find a virtual machine management system, you'll find a hypervisor software that talk closely to the hardware part of your rack or the server that is hosting those virtual machines, and then those virtual machines will work together on the same rack. Now, this is very interesting and very good, and we have been using it for more than decades, and it is still used till today for many use cases. But we eventually know that there are some cons with this style, because if we take, for example, the server replication, if you want to replicate your server or replicate your virtual machine, then you see clearly that it takes a little bit of time because the size of the virtual machine is usually big. Why the size is big? Because of the operating system. It has to replicate the operating system. Even though we normally don't touch the operating system, we don't modify the operating system whatsoever, but you need to replicate the whole operating system. And in case of failure, then you will need to wait at least the time for booting up a complete new operating system from scratch. So that is basically the downfall of virtual machines. While it is okay for some enterprises and some companies, this is the best solution that serve their needs. We also offer some other set of services where we tell you, hey, how about we take care of that behind the scene for you? You don't really have to look at the virtual machine. You don't really need to know what's going on behind the scene. We will abstract the services from your actual code. We will give you a platform, you put your code, and we will run it for you. And that is basically what we call App Engine. So it's a complete different side of the spectrum. And when it comes to scalability, eventually you will see that this piece of code or this piece of software that you have written is basically replicated quite independently and without any effort from your side. You just set the rule and set the limits. And Google, because it's managed by Google, then Google will take care of the scalability automatically. Of course, we have like automated way of how to deal with those certain cases. Now, between the complete flexibility of IaaS and between the complete like control of the App Engine, we have in-between solution, what we call containers. So containers is basically the idea of telling you, I will give you a flavor of operating system that is ready made and ready to be used, and you just place your container or place your application and library on top of it, and it will just work. The operating system, you don't have to worry about it. You don't have to worry about how it's being managed or its availability and durability and so on. It's completely managed by Google. You just take a container, an image of exactly software and libraries, and put it on top of this container optimized operating system, and we will take care for the rest for you. So this is the idea of containers, and this is basically a global idea, not just related to Google. As I said, you will find it in other cloud providers. You can imagine basically the advantages of something like this. Basically, in terms of scalability, it's quite easy because, again, you don't have to worry about the operating system. You don't have to worry about the low-level duplicated tools that we will find in everywhere. You only need to worry about basically your application code. So you ask your developer to basically create a containerized application, and once you take this standard containerized application, you can put it inside Google, you can put it inside your on-prem container orchestration system, or you can put it in other cloud provider. It also, as I said, works quite seamlessly across other cloud providers. So if you are going for hybrid cloud, or if you are going for multiple cloud providers, or even if we are worrying about the problem of a developer telling you that, hey, it works on my machine and I have no idea why it does not work on the cloud. So you will not run into those issues, because that is the promise of container. You develop once, and the containerized version that has been developed will run everywhere. Any place where there is a container orchestration system will just take the exact copy and will run it exactly the same way how it used to work on the developer platform. So this leads us to get an introduction about what is Kubernetes exactly, what is it doing exactly. So the story behind Kubernetes, basically, we at Google, we have been using containers since many, many years ago, and we have decided to open source a similar version to our container orchestration system that we use internally at Google, and we call it today Kubernetes. So Kubernetes is a complete open source solution. It's owned by the community. Of course, Google is probably the major contributor till today, but it is basically owned by the community, and it is arguably the one of the best and the most robust container orchestration system used by all cloud providers. Wherever you go, you will find, definitely you will find Kubernetes as one of the services. So that is the deal about Kubernetes. As I said, it's a complete open source solution. To start to use it, you can start by defining your application code. So the examples that you see in front of you is basically an application written in Python. You can use tools such as Cloud Build or any other preferred tool for building containers. You're provided with what we call a Docker file. And optionally, if there are some requirements or libraries, you need to provide those as well. And that's pretty much it. So the source code, the Docker file contains the definition of your containers, and then a definition of all libraries and all external dependencies that your application need. And then finally, you type in Docker build, Docker run to build and run your container. So that is the system that will pretty much work with more or less any other container orchestration system. If it supports Docker format, then it will go over pretty much similar commands. But then the interesting thing about Kubernetes is that it creates what we call a cluster. And this cluster need to have a master node that is responsible about the APIs, the administrator APIs to manage the cluster. And then you define the number of nodes that are going to be available inside your cluster. So so the master node is not going to be accessible by your users. This is not a public instance. This is only for you as an administrator, and this is for you to be able to communicate and talk to the other nodes, such as telling, I want to deploy a new container, I want to restart a container, I want to manage something in the system, and so on. However, if you want a managed version that is creating everything for you, then Google Cloud has what we call Kubernetes Engine. So Kubernetes Engine is basically a managed version of Kubernetes inside Google Cloud. You can create a cluster by simply typing a command such as gcloud container cluster create and then give it a name such as K1, and that's pretty much it. Of course, from Cloud Console, you can also click on Kubernetes Engine and then clusters and then create, and then you will be greeted by a form that asks you for the name and some other configurations such as number of nodes and so on. And that's pretty much it. That's all what you need to start with to create your cluster. So taking away the hassle of managing and creating virtual machines and managing the connection and the network and the firewall rules and all those kind of things, the master node itself needs a little bit of hefty software and a lot of configuration that need to be created. But then with Google Cloud, you don't have to worry about it. And moreover, the master node is completely managed by Google, so you don't even need to worry about its existence. It is going to be hidden from you, and you can come, like, we provide its high availability and we provide its resiliency. You just need to communicate with it so that it can manage the rest of your cluster. Today, inside Kubernetes, when we are deploying a container, you cannot just put it like that. We use something called a pod. So think about it like a gift. You want to gift someone or send someone a laptop. Will you take the laptop and put it in the post and ask the postman to send it like that, or you will wrap it inside a box first and then put it in some sort of format? So this is exactly the same thing inside Google Cloud, or inside, not necessarily Google Cloud, but inside Kubernetes. You need to put your container inside the pod. The pod will give you some sort of functionalities for your container, such as shared network space and shared disk space, especially if you want to have multiple containers to run together. To give you an example, if today we are talking about an application that needs to have a monitoring agent to be running together all the time, the monitoring agent does not make any sense to run alone because it does not have anything to monitor, and the application should never work alone without being monitored. So you create two separate containers and you put those two containers together inside one single pod, so that if that pod fails, or if one container fails, then that pod fails, and then those two software always start together and turn off together. The command that you see in front of you is basically how we start by deploying your containers inside the pod, and we use kubectl. So kubectl is the command line tool. It's also part of the SDK, or you can find it inside Cloud Shell. Basically, it is the command responsible about deploying your pod or managing pretty much everything inside your Kubernetes cluster. So remember, when we started to create the cluster inside Google Cloud, we use the command that is specific to Google Cloud. It's called gcloud create cluster. But now I have the cluster and I'm connected inside the cluster. Once I've done that, then I need to type in or use the Kubernetes specific command line, which is kubectl. So here's an example, kubectl get pods. Basically, it will tell me how many pods have been deployed inside my cluster. By default, the pods are invisible and they are only available within your cluster. But if you want to expose them, you want to make them visible to other clusters or maybe visible to the internet, then you need to use some sort of service, such as a load balancer. So here is an example where I'm trying to create a load balancer on port 80 for the outer world, for my other clients to be able to access my services. And remember, we are not going to expose the master. The master needs to always stay invisible and private. We are only exposing the nodes. You can also have advanced tools on top of your cluster and on top of your pods as well, such as specifying the replication. So here, for example, is a command that defines that I want to specifically have 3 replicas of my pod. I want to always have 3 versions of my pod for higher availability to be always available. Now, if you don't want to specify the number, if you want to make it auto scale, then there is also another command and also another configuration. You can, all those commands that I show you till now are basically doable from the console as well, like a configuration. But I'm showing you the 2 flavors so that you can find it inside the console, or you can also know how to do them from command line. The bottom line here is basically I'm setting an auto scale mode for my cluster, for my pods, to not go less than 10, but not exceed 15. So I have here a budget. I cannot exceed 15 pods, but I also want to make sure that I have at least 10 running at any point of time. Now, my parameter here, that's the decision that is going to decide if I need to scale up or scale down, is the CPU. Am I exceeding 80% of the CPU consumption? If yes, then add more pods. You don't necessarily have to all the time make an imperative way and type commands. You can also use a declarative way. So the example that you see in front of you is how to define my whole cluster and define my deployment strategy through a YAML file. So basically, I'm defining the container, the version, the replicas, and so on. And then I'm applying this, and it will be applied inside your cluster. This is a very interesting and advanced way of how to deal with your cluster, because you want to document and have a version of what's going on. You don't want to just type commands and then forget, what did I type? What went wrong? Why it's not working anymore? So instead of running into those type of issues, maybe you can just create a declarative file, a YAML file that has all the declarations of everything that you want to deploy inside your cluster. And then you also can have versions of those YAML files for future upgrades to understand what has evolved. So back to the examples that you see in front of you in the screen. You see here, for example, I had replicas to be set to 3. Now, if I change that to 5, for example, then I need to reapply the new modification. So the command here will be kubectl apply -f, and then I give it the YAML file, the name of my YAML file, and the final result will go to, if I type in kubectl get deployment, it will go to 5 pods instead of 3. One thing you might have noticed that I have 2 pods per node now. Yes, that is of course possible. A node can have more than 1 pod, unless if there is a requirement that prevents something like that, then one node can actually have multiple pods, depending on the current number of pods that you have requested. In my case here, I had only 3 nodes, but I requested 5 pods. That's why some of my nodes must get more than 1 pod. And there are other declarative formats that or declarative functions that you can have. So here, for example, I'm showing you that you can also apply rolling update with max surge and maximum availability of your pods. So those are some strategies for upgrading your application from one version to another, unless this upgrade requires a total shutdown of your whole system and restart from scratch. If it's not a major upgrade, if it's a small upgrade, then maybe you can apply a rolling update strategy and tell, for example, that I can kill at most 1 pod, and maximum unavailable is 0, so I cannot afford not available pods. And with that, I will leave you with some further reading in those resource links. Next, let's talk about applications in the cloud. Remember earlier, we opened the topic about App Engine. We said that it's an interesting way to just put your code and we take care of everything, we manage everything behind the scene. So what is App Engine exactly, and what are the flavors of App Engine? This is what I'm going to discuss in this section. So App Engine is a platform as a service, Behind the scene, it is actually a container. So drum roll. Basically, it's a container, but it is completely managed by Google, so that you don't really need to worry about the cluster, the auto update, the max search, the max, all those kind of things are taken care by our engineers, created in some sort of templates. It has some sort of supported programming languages, but then when you just set up, once you have just set up everything as intended, then it will work out of the box. Is App Engine for you or not? Well, it depends. If all you care about is just some code and you don't really need major customization and major infrastructure involvement, then App Engine probably is your best friend. But if you are making some sort of low-level transactions, or you require some sort of control on your machine, then maybe you need to figure out with other solutions. So the flavors that we have with App Engine, we have the standard and the flexible. What is the difference? So the standard version is actually the very old version that existed since ever, and probably the most notable thing about it is that it comes with a free tier. I know many businesses that are using App Engine free or standard for free. That is especially when you don't have a big number of visitors and a huge number of flow onto your service or backend or maybe website. So that is App Engine standard. But of course, that is not the main advantage. The main advantage is that basically it's easy to start with, and it is easy to just deploy and get your application up and running. You don't care much about what's going on behind the scene because it is 100% managed by Google, as I said earlier. So this is one example of the workflow. You just deploy using the provided App Engine SDK, which is pretty thin at this point. You don't really make any much configurations. You deploy your application, and then you can use some of the built-in solutions such as Memcache, task queue, scheduling tasks, and so on to manage parts of your application. App Engine Standard is excellent on this front, but if you need to provide your own custom libraries, or if you want to have support for .NET framework, Microsoft.NET, then this is where you must go for App Engine Flexible. So App Engine Flexible is more or less the same concept, except that it gives you a little bit more flexibility in terms of library support. It supports Microsoft.NET, and it gives you some more flexibility on hard disk access. The access to the hard disk is ephemeral, but at least it gives you some sort of access if you want to store temporary or cached files. So this is more or less a comparison between the two flavors. As you can see, the standard one starts in milliseconds, so quite fast, but the flexible environment takes a few minutes, and that is for starting the instance. Once it's up and running, then pretty much the flexible gives you flexibility in all fronts. And when we talk about the programming languages, you'll see that the flexible supports all programming languages, including Microsoft.NET. The App Engine Standard support a subset of those programming languages. Actually, here it's not listed all the languages. There is also now support for Node.js and Ruby and so on. So App Engine Standard is more dynamic, more fast, but give you some little limitations. App Engine Flexible gives you even more flexibility. One interesting thing about Flexible is that you can at any point export whatever you have inside App Engine Flexible as a container and use it inside a containerized environment. So you are not really locked in with App Engine. I know it's closed source, but you are not really locked in with it. And you can just take whatever you have built there as a container and then use it, for example, inside Kubernetes engine to continue work there. Remember also that migration from App Engine Standard to Flexible is possible, but you cannot revert back once migrated. If you want to revert back, you have to create a new project from scratch. Now, last but not least, let's also talk about endpoints and APG. So those are important points for, especially for developers when we are developing managed applications. So what is endpoints. Before I talk about endpoints, let's also talk about what is an API. API, or Application Programming Interface, is basically the language to communicate between your front-end application and your back-end application. The example that you see in front of you on the screen, basically my complex back-end application that does not necessarily need to be visible for my clients. And here my clients are developers, right? So my developers who want to interact with my application don't necessarily need to see my code and my complexity and what's going on, and especially if I'm making major upgrades and modifications, continuous modification to my system. I just provide them with some sort of interface, an API, a way to talk to my application, and they implement their modules to talk with those APIs, and then both of us will be working even though we never sat together and we never had any programming or pair programming together. You can see this clearly when you are using YouTube APIs, for example, or Google Maps APIs and so on. You don't necessarily see how Google Maps work internally. You don't see anything whatsoever inside the black box of Google Maps, but basically you use the APIs to get data from Google Maps and display that data inside your website. So more or less it's the same thing when you are developing any application and potentially have developers that want to access your application. You need to create some sort of API. And for that, we provide you with what we call cloud endpoints. It helps you maintain your APIs and export some edge points for your developer to use your application through a RESTful APIs. Cloud endpoints supports pretty much any sort of client, whether it's an Android device, iOS device, or JavaScript. And JavaScript pretty much means that any web browser, right? So that's for the client side. And for the runtime environment, cloud endpoints will work great when you are using App Engine Flexible, Kubernetes, or Compute Engine, of course. Now we have a new product as well, which is APG, that is coming from one of the newest acquisitions. Basically, it's a platform for making and interacting with your APIs in terms of customer point of view. So you can monetize your APIs. You can have some sort of analytics on top of your APIs, understanding the demographic of your APIs and so on. And you can monetize your API. So, for example, you can set some sort of pricing, let's say a price per unit or price per request or price per interaction and so on. So this is going to be helpful and straightforward when you are selling your APIs. APG also helps you very well when you want to secure and authenticate your APIs. So some APIs might not be possible for anyone to just use. You want to make sure that it's coming from the correct developer, and API will provide you with a nice interface to do that. And for further readings, I will leave you with those links. All right, so let's head to the last section of today's journey, which is developing, deploying, and monitoring inside Google Cloud. So in this section's agenda, we will be talking about some other development inside Google Cloud, and then we will talk about the infrastructure deployment and how to do that with coding. And finally, we're also going to talk about Cloud Operations Suite. So for developers, if you want a place to host your source code, you are probably looking for some sort of Git repository, and Google Cloud provides you with Cloud Source Repository with some sort of a free tier that you can use, and you can securely host your code inside Google Cloud. Well, I know that some people have, well, I mean, there are plenty of Git repositories out there on the internet, but the advantage of using the one inside Google Cloud is integration with other cloud services. So today, if you want to have your source code to be automatically pulled and used inside some sort of pipeline or build mechanism or some sort of internal management, then you will find further support or even higher support when you are using cloud source repository. It also gives you a visibility to map your permissions and cloud IAM rules on the source code directly without having to set or create external accounts. So if you are using a third-party Git repository, you will definitely need to create other accounts for that source repository. But then with cloud source repository, you don't have to do that because your users are already there. Well, it's a matter of flavor, and of course, everyone prefers to use a specific tool, but nevertheless, it is a service available today inside Google Cloud for the developers out there. We have also Cloud Functions, and Cloud Functions is serverless, stateless methods that you can place inside Google to be triggered based on specific interactions. So today you want to, for example, monitor when a photo has been uploaded, to take that photo and send it to a certain processing unit to shrink this photo and create a thumbnail out of it, for example. So you can create a cloud function to exactly do that for you. Well, you need to use PubSub for that, for the mastering service. But then once you take the event, you can basically execute the function based on it. So those triggers and those small functions, instead of building a virtual machine or container for doing them, you can just put them inside Cloud Functions. And the interesting thing about Cloud Function is that you don't pay for an instance up and running all the time. You only pay per execution. So if nobody triggered anything within 1 week, you don't have to pay for the instance up and running for 1 complete week and not used. You only pay for the number of executions that has happened on your functions. Now, I talked about the part for development. Now let's talk about the part for DevOps. When you are deploying your application inside your infrastructure inside Google Cloud, you probably maybe will experiment with console, with the graphical user interface. You maybe will experiment as well with the command line, but eventually for growth and scalability, you are definitely looking for something that can be retained for a longer period of time and have a good declarative format. And for that, we have what we call Deployment Manager. Deployment Manager is a way to declaratively define what the infrastructure looks like and then apply and automatically create your infrastructure. Eventually, you can take that code that created your infrastructure and put it inside a source repository, for example, for versioning and control, reviews by peers. And whenever you are upgrading to a newer version, you can understand what has went exactly inside your system. Nevertheless, you can revert back to an older version if needed. Google Cloud does support Terraform as well as other third-party tools. So if that's what interests you, all of them are supported, but the native versions or the native software that exists inside Google Cloud is Deployment Manager. And then last but not least, actually it is one of the most important parts, is the Cloud Operations Suite. So what is the Cloud Operations? Cloud Operations are a set of tools that help you monitor and understand what's going on inside your system, and sometimes interact with the system to understand what went wrong. So it comes with monitoring, logging, debugging, error reporting, tracing, and profiler. So what are those? The monitoring and logging are pretty much related. The monitoring is basically understanding and seeing what's going on inside your system. You want to understand the system health, the uptime. You want to understand if things go as intended, if there is a problem, if there are errors. You can set some sort of alerts. All of that are important. Why? Why it's important? Mainly because you want to, first of all, have some sort of prevention before things happen. So if you see a specific pattern inside your system and you predict that if this pattern continues like that, then a problem will happen in the future, then you can prevent it. But also mainly to understand what exactly went wrong inside your system. So let's assume that there is an incident that happened, but you don't have a monitoring agent. You don't have a security camera that is monitoring what's going on inside your system. How would you know what went wrong? So the monitoring, along with the logging, will give you a tool to be able to go back and understand exactly what went in the system and understand the source of the problem and hopefully fix it before it happens again. So that explains the logging part. Logging is quite crucial and important to log every single interaction and what's going on exactly inside your system. And if ever you want to have some sort of error reporting, so that is the fourth tool here in front of you, error reporting that can give you some sort of notifications and even errors that can be displayed inside the dashboard whenever there is a problem. There are two types of errors. There are errors that are built in and automatically triggered whenever there is a problem. And there are errors that your developers can use. They can integrate the SDK tool for error reporting to report directly from within your application to the dashboard. Something like, okay, I'm running out of space, or I cannot connect to the database. You don't want to flip around and try to figure out what went wrong. To be able to do that, you simply can ask your developer to use the SDK for error reporting and see those issues directly inside the dashboard. Now, if the error message is not clear enough and you want to understand what went wrong exactly inside the source code, we also have debugger that can be used exactly inside your source code to understand the exact line of code and the root cause of the problems. So this is also built in inside the cloud. This is some sort of understanding what went wrong in production. I know that there is debugging, of course, in development mode. I mean, the developer on their computer, they must have a debugger, but now we went production and things are working. But I just still want to understand what went wrong, what is the line of code that is causing the issues and producing errors. So that is also visible inside your Google Cloud Platform. Similar to the debugger, if you want to debug the network issues, so I will go back to trace. Trace is number 3, the column number 3 that you see in front of you here. It's basically for understanding the latency problem inside your network, the bottleneck, where the cause issue, and understanding exactly what's going on in terms of networking inside your Google Cloud applications. Last but not least, there is the profiler that helps you to profile and benchmark a certain part of your Google Cloud services to understand what they are consuming exactly in terms of resources, consumption, and maybe also understanding the scalability of your system and understanding what might be needed. So if you know, for example, that you have a certain number of users that are going to access your application, then you can profile your system and understand if your system is going to be able to operate normally under that number of users at once. So Google Cloud operations are quite important to maintain a good scalability mechanism and maintain uptime for your application without facing too many issues. Of course, it's not about a person that is going to be sitting in front of the monitoring tool and looking at the charts to see what's going on in the system 24/7, but it's also more about smart tools that you can use, such as alert and fast interactions, so that once an SRE or site reliability engineer receive a certain alert, they can go to the operations suite and they can understand the root cause of the problem and fix it as soon as possible before it propagates. Besides the alerts, as I said earlier, also make a continuous read of your reports to understand if there is a potential problem that is going to happen eventually soon. And here are more resources and links to continue reading on those topics. With that, I would like to thank you so much for sticking around today with our journey on Google Cloud OnBoard. I hope it was helpful for you. I did enjoy. I hope you enjoyed as well. And I'll see you next time.